Okay, in this video we're going to look at some of the practice solutions for permutations. Now a permutation is a possible arrangement of an ordered set of objects where we use the equation NPR equals n factorial over n minus r factorial. And n represents the total number of objects and r is the number of slots or objects chosen that we have. So number one, we have 7 total objects with 5 slots. So we can use the formula 7 factorial over 7 minus 5 factorial. And 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1. And then we can simplify this. I need to get the calculator here. Okay, so the factorial means we take the number and multiply it by the next natural number descending until we get to 1. So after I simplified this, it's 7 times 6 times 4 times 3, which is 2,520. Okay, so in example 2, we're going to do the same thing except multiply the two permutations once we find them. So we're going to find 4p2, substitute into the formula, and we can see this simplifies nicely to 12, and then 5p3, so it'd be 5 factorial over 5 minus 3 factorial, which is 5 factorial over 2 factorial, so that means it's going to be 5 times 4 times 3, because the 2 and the 1 will cancel, which gives us 60. So I want to evaluate these two multiplied, so I just take 12 times 60. And my answer is 720. We'll see something like that on the last problem of this practice set. Okay, number 3, how many different 4-digit numerals can be made from the digits of 5, 6, 9, 8, 7 if a digit can appear just once in a numeral? Okay, so we have 5 possible objects, 5, 6, 9, 8, 7, and only 4 spaces. So this would be 5p4. Okay, so we get 5 factorial over 5 minus 4 factorial, which is 5 factorial over 1 factorial, which is 5 times 4 times 3 times 2 times 1, which is 120. Okay, number 4, in how many ways can 6 students be chosen from 9 students if the order in which the students are chosen matters? So we have 9 students and only 6 spaces. So this would be 9p6. So I can actually say 9 factorial divided by 3 factorial here, which is 60,480. So we can use the factorial function on the calculator to help us solve some of these problems. Number 5, a TV station has 8-hour-long TV shows to choose from in order to fill 2 one-hour time slots. Okay, so we have 8 shows and only 2 slots. So this is 8p2, which is 8 factorial over 8 minus 2 factorial. This is just going to simplify nicely to 8 times 7, which is 56. You could try this on the calculator. 8 factorial divided by 6 factorial, 56. Problem 6. A basketball league consists of 12 teams. In how many ways can the teams finish in first, second, and third place? So we have 12 objects and 3 spaces. So this would be 12p3. So this would be 12 factorial over 12 minus 3 factorial, which is 12 factorial over 9 factorial. Everything from 9 down is going to cancel here. So I get 12 times 11 times 10, which is 1,320. Let's check it on the calculator. 12 factorial divided by 9 factorial. Yes, 1,320 is our answer. Number 7, the last one, and my favorite problem. A secret code consists of 3 digits from 0 to 9, followed by 2 letters from A to Z. So we have 2 separate permutations to calculate here, and then we're going to multiply the final. So in the first part, I have 10 objects with 3 spots, and the second one, I have 26 and 2 spots. And the code is going to be the 2 permutations multiplied. So 10p3 is the first one. I calculate 720. 26p2 is the second one, and I get 650. And the code is multiplying these 2 combinations together. 720 times 650. There are 468,000 secret codes possible using the 3 digits 0 through 9 and then 2-letter combination A to Z.